All right, so thank you. And I see we've got people from as far away as LA. Um, I happen to be in San Diego at the moment, so that's good to know. And I'm assuming that there's some folks from Georgia here as well. Um, and some people have obviously been at the panel this morning, so that's good. And we're going to have a deeper dive into that. So I am going to start sharing my screen and hopefully not mess it up because that seems to be one of my favorite things to do. And although we're going to be talking about the ECS curriculum, the PD, and community, I also want to start with some background because I think the background will help address some of the questions that Lynn uh, asked about as we got started today. So I'm about to share my screen and hopefully, there we go. So as promised, we'll start with some background. And I'm including this slide with this particular quote because I think it strikes at the heart of where we are in CS education today and will help ground our conversations about how and why ECS came into being and why it's still important today. So this quote, what we have learned about swimming and computer science is that all of the seemingly cultural preferences and interests are profoundly impacted by historical legacies, structural inequities, denied learning opportunities, and belief systems that justify these inequities. And this quote by Jane Margolis, the primary authors of Stuck in the Shallow End, really resonates with me on multiple levels, but struck me today in particular because it was 5 years ago at the 2016 Olympics that Simone Manuel was the first Black woman to win an individual gold medal. And, she just qualified for the Olympics again this year. And that whole notion of historical legacy that's part of it turns out to be also true of computer science. And that's essentially where we started, right? Rewind to 2020, which is 21 years ago, according to my calculations. Jane and her research team were in 3 schools in LA Unified School District researching to find out why there were so few students of color and girls enrolled in computer science in a school district that is primarily Latinx and Black. And so the findings that were documented in this book, which was originally published in 2008 and updated in 2018, are the catalyst for exploring computer science. Because these are the findings, right? A whole set of systemic and belief system issues that came together to paint a picture of the fact that the reasons for students not being in those classes had very little to do with interest or ability, in quotes, defined, right? There was generally a lack of diversity in these areas, largely because people were making assumptions, right? Preparatory privilege was seen as an innate thing, right? Interest and knowledge was just part of the DNA of students, when really it was because perhaps they had had opportunities at home. There was a culture of low expectations in many of the schools that were present. The curriculum didn't connect with students' experiences. Counselors were steering people away. Nobody really quite knew what computer science was. And there was a tremendous variation of course offerings between schools in this very large school district that is extremely diverse. And what strikes me here is that not much has changed in 21 years. I just seen articles and comments published recently that only 47% of high schools offer a computer science course of any kind. AP CS Principles came into being, and it really took off and has been a great progress in terms of numbers of students, but the number of historically underrepresented students has not changed significantly. And so we decided that it was a necessary thing to come up with a course that would address these things, right? So at the time that we started conceiving of ECS, it was 2008, and we were really only developing it for Los Angeles Unified School District at their request, because they had received the results of the research. They had worked actually to get more students enrolled in advanced placement, more students of color in advanced placement, and were successful in increasing numbers. But what didn't change, and keep in mind that at the time it was only AP Computer Science A that was being offered, students were not interested. They didn't see themselves in the classes in general. Some of that was addressed through the early work in LA. But more importantly, they didn't see any good reason to be taking a computer science course. So when my colleague Joanna Good and I decided to take this on, we started with three main overarching themes. Computing is creative. Computing has technology for solving problems, and it's relevant to computer science and society, the relevance of computer science and its impact on society. And if you were part of the Coded Bias watch party last night, you know that these things are still key tenets to what we need students to be learning in computer science today if we want them to be the creators and the thinkers of the next generation with jobs that don't even exist today. So we also started with three key intertwined principles that we have computer science, but teaching computer science as a list of this typical standards, do this, memorize this, those kinds of conceptual ideas, or coding as the only thing that we're focused on was not where we wanted to go. And so we drew from research from other STEM disciplines that shows that inquiry is a way to engage in particular concepts, whatever those might be, in ways that tap into students' prior understandings, that get them excited about doing the work. And that all along in this, we're thinking about how do we build a classroom culture that is equitable for all students, regardless of where they come from, what backgrounds they have, whether they've had computers at home for their entire lives, whether they speak English as a first or secondary language, wherever they've grown up, whatever cultural background they have. So we're continually trying to think about those three key strands as we're designing this course. And then we had the task of trying to decide, well, what content? Computer science is huge, right? It's a field that spans a wide variety of things. And what would be the best way to introduce that to students? And in what order should we teach these concepts? And what we came up with is one possible configuration of the types of content that students might find interesting. But the idea in general was to provide a window into the breadth of what computer science could offer students and make sure that whatever we did provided opportunities for them to see potential careers, but also potential ways to interact with the world in the future. So we started with the 6 units listed: human-computer interaction, problem-solving, web design, intro to programming, computing and data analysis, and robotics. So those were the first 6 units that we developed. And over the last several years, we've worked on 2 additional units with other research projects: artificial intelligence and electronic textiles, which are designed really for more experienced teachers to tackle. And they are potential replacements for units 5 and 6, the computing, data analysis, and robotics. The design is also purposeful in that it builds, right? There's a daily lesson guides for each unit. And notice I said guides, not scripts. I will come back to that piece of it later. The lessons spiral, the units spiral. So in unit 1, we introduce early versions of each of the topics that come into play in the later units so that students have a reference. That first unit is intended to build the culture in the classroom, a culture of inquiry, of collaboration with the teacher and students learning together. One of the things that we'll discuss more when I get to the PD part is how important it is to help teachers understand that in computer science, they're never going to know everything there is to know. It's impossible. It changes every day. And so for teachers to be able to exist in an inquiry-based world is really important as well. So that human-computer interaction unit is intended to make it easy for all students to find a place, right? So anyone from someone who's never really had computer access at home to somebody who's been programming in Java on their own for 10 years. That's an extreme example, but mostly there's a lot of people in between. We think of students as digital natives, and often they know a lot about certain things, but maybe not as much about others. Like if I'm using the internet, what are the privacy implications? How might I want to think about my passwords so that I'm not leaving myself open to cyber attacks? Those kinds of things that, again, impact in connections to the real world. Problem solving is really the core underpinning of the course, and units 1 and 2 are basically the foundation. Building a culture and focusing on a process of problem solving that can be carried over into more reinforcing activities like web design and programming, so that by the time students get to those 2 units, they're planning their work, not just diving in and hacking at the computer. I think this becomes especially important when we get to the introduction to programming, because that's utilizing Scratch. And one of the common things that I hear now, 20 years later, is that my students have already done Scratch. And I liken that to my students have already done math, because there are levels of interaction with programming. And by the time they're in ECS, we're expecting them to be able to analyze the computational work and work of others. So is this the most efficient way of doing it? Are there other ways? Might I not be able to explain it to somebody? If I can't explain it, is it any good? Right. So those are all things that we need to think about. And then the applications units, computing and data analysis, thinking about big data. How do we look at different visual representations of data, which are better, et cetera. And robotics, we use Edison. We used to, in our very first iterations, we were using Lego Mindstorms, but those were very expensive. And as an equity-focused program, we felt that once there was a better opportunity for this course, that we would switch over to something that was less. We also leverage other research-based programs. And one of those is Computer Science Unplugged. We have several activities that are built into the ECS daily lesson guides that make use of CS Unplugged. And we also make use of culturally situated design tools, particularly the cornrow curves and the bead loom activities. This is a great site and great resource for anyone who wants to be able to provide some very culturally relevant activities, places where students can see themselves in the curricular materials, and keeping in mind that it's also important for students that are not of a particular cultural group or race or ethnicity to see what others bring in their cultures. I think too often we think, well, there's nobody in the room that is represented by that particular cultural artifact or hairstyle or any other examples that you can think of. And even more important for them to learn about the fact that there are more cultures out there than their own. So all of this leads me to professional development, because it turns out that you can have a curriculum that you've designed with particular principles in mind, and it still can lie flat. And when you write a curriculum that is scripted or that is intended to be picked up by a teacher without any professional development, what often happens is you have examples that teachers use just as is. And we very deliberately designed ECS so that it could be culturally responsive, culturally relevant, right? So that we meet students' needs and we show students in the curricular material. So if I'm teaching in LA, the students in my classrooms may be very different than students in rural Montana. How does that change the way that I approach things? If I have students that have never engaged in collaborative work, what do I need to do to build in some scaffolding for that so that, you know, adults don't just naturally collaborate? So why would we think students would? So the professional development is, in my opinion, really more important than the curriculum. I think what we've learned over time is that when teachers come back year after year, they say, I'm doing this in my other classes. And, to us, that's a win, right? Even if they don't teach ECS anymore for some reason, the change in teaching practice has made a difference in other classes. So we have a 2-year PD, and that design starts like many PDs do in a 5-day summer institute. During that first summer, we dive into inquiry right away. We talk about culturally responsive teaching practices and model them. And we do something called teacher, learner, observer, where teachers actually plan lessons from the ECS curriculum together, teach them to their peers, and then we debrief and talk about how those particular strategies that were used might impact students in the classroom. As teachers, how did it impact you? When you were being a student, what would that look like in the actual classroom? And this is where that difference between a lesson plan on a page and a lesson plan enacted is different. Anybody that's ever taught a class at any level knows that what seems like it's going to work with your students may not work as intended. So this is a rehearsal opportunity with collaborative wisdom. And that focuses on units 1 and 2. Then we have quarterly Saturday. This is an old graphic, quarterly Saturday workshops. We have all kinds of quarterly configurations now because of different geographical issues, et cetera. But for quarterly experiences that dive deeper into additional units. And in some areas, we have classroom instructional coaching. We know that that's helpful. That ends up being one of those things that often gets left out because of finances. We also have an ongoing teacher professional community. And then they repeat that summer institute in the second summer. And here's a different form of the graphic that ties the specific summer, quarterly, and second summer activities to the units in the ECS curriculum. So you can see again that units 1 and 2 are the primary focus of our summer, because that is, again, for teachers, it's also building the culture. It's about building an empowerment of the teachers. And then these quarterly PDs dive into the units. And then that second summer, what makes this different, and one of the things that often happens in early adopters is, well, why do they have to come back for the second summer? Why do we have to do this? Well, the very nature of the way the PD is designed, with teachers planning and teaching lessons, is such that you never see the same lesson the same way twice. And so you have this opportunity to come back for the second year after you've taught it once and realize all the things that you wish you had asked in summer 1. And I'm really seeing that, as Lynn pointed out. I'm in the middle of doing a PD this week, and the only reason it works is because we have some virtual time. But it's always interesting to see how much of a change there is with the second year people in the room. They've different language in speaking about things, recognition of different things. And I've talked about most of these things already. The features of ECS PD, like inquiry, this teacher, learner, observer model. One of the things that I haven't talked about is this focus on equity belief systems and teaching practices coupled with race conscious conversations. We actually read the book Stuck in the Shallow End as part of the professional development, and we have conversations about that and how uh, the ways we talk about race in our classroom are important, that our own personal belief systems can impact what happens in that classroom, and how do we check those biases at the door before we go in. And again, empowering teachers to become the facilitators of the classroom, the facilitators of a professional learning community in classrooms. And somehow wrapping all of those together in a package of, basically a year of work, hoping that it will all kick in. And we also build teacher leadership. One of the driving forces of what we do with our professional development model is the belief that teachers are the leaders and teachers should be leading teachers. And so I'm often one of the early facilitators for a new project, but the goal is for me to work myself out of a job, for local teachers to take over those responsibilities. And so during that second summer, we start to identify people that we think might be able to step into that role. And then we have a mutual discussion about, some people are just not that interested. They prefer other leadership opportunities, but that's one of the main things that we do. And then we have multiple communities, all right? As I noted, we have the ECS facilitators, and we bring those teachers together every year for an update. We talk about what happened the summer before. We dive into the research that is part of the work that we do. The last several years, we've had sessions at a CSPD week where we've brought a whole lot of people nationally together. And so that group of people has been a group that we have more interaction with than our normal regional partners. And so a lot of research has occurred during that. And most of the research has been on the kinds of conversations that teachers have around Stuck in the Shallow End. So we work with our facilitators to continually increase their knowledge. And you'll see these little squares over here on the side. That's our facilitator meetup this year because we couldn't all be together. And then we have ECS teachers within regions. So for example, we have several projects going in Alabama, and those teachers are, become part of a very large community as new teachers come in. Teachers within a school site, that's not as common, with only 47% of schools offering it. And then many of those schools only have one teacher. That's a harder thing to fill. But we have a national teacher network. And of course, we have the ECS students. And then I really want to kind of cycle back to this notion of culturally responsive pedagogy and practice, that this is really about those themes in the beginning, right? Because we want to be able to connect with students' culture and life experiences and empower students to become change agents in their lives and build relationships with students and families and communities. So this is only possible if teachers feel empowered to modify lessons, work with the curriculum in the way that we hope that it can be implemented. And with that, I'm going to just dive very quickly into this particular chart. And I'm going to stop sharing my screen for a minute after you've had a chance to look at that. So I'm curious, after seeing that chart, what your first reaction was, and what are some questions you'd like to ask about it? Anybody? Scott, can you, can all right, what can be done? I understand. Okay. I was going to ask for clarification, but I'm guessing that what you mean is how do we fix this mess, right? What other questions might you have just about the chart itself? Yeah. Okay. Those are good. Those are good first reactions. I like that. I am curious if you have any questions about that chart. Okay, why is there such a gap in the US? All right. Take one more, somebody. Who should be part of the solution? Okay, how would you answer those questions? What would you do? All right, your interest was sparked. What would you do to respond to those questions? What would be some of the steps you would take? Research first. Okay, what exactly does that mean? Okay, so I'm gonna jump in because um ah interesting. All right. So the point of this exercise is multifold, and I just threw it out at you and kind of randomly out of context, so probably not fair. But this particular activity, first of all, one of the things that, after I saw this for the first time, which was a long time ago, by the way, um, my initial reaction was not printable. And in several workshops that I did that particular year, I literally heard other things that were not printable. And then people started coming back to earth and asking questions like, where did this come from? Who, why these particular countries? When was this chart um, from, right? Is it recent? Is it, last year? And so it turns out that this is from somebody's blog in 2011. And so, one of the ways that we could use something like this in ECS, there's multiple places that we could use something like this in ECS. You could use it in Unit 1, right? Just to get students to start recognizing that not everything on the internet is factual even, and maybe you need to do more research. You can use it in Units 2 and 5 to get started on discussions about data collection and making a social impact by, making a case or discovering something. And in particular, something this simple, right? This might not be the one for students that would get them excited, but something this simple that connects with their particular interests can be motivating. So, thinking about things that are in current events as one of the ways to spark students' interest and be culturally responsive to their particular ways of thinking and being is important, right? And it doesn't have to take away from the lesson. It can be a very quick journal entry like this would have been if it had been in a classroom. So I use this as an example just to show that we can spark interest very easily and quickly with just the right choice of items. So I'm going to close with a last slide, I hope. Right. And this is a slide that was created by my colleague Joanna Good to show kind of the challenge that we have in computer science for all, right? And this cycles back to Lynn's opening comments too, right? So we've done, as a CS community, a lot of access work. We've tried to get courses started. We've tried to get the community involved. We've found champions. We've found administrators. We've even found partnerships. We've moved into a lot of areas of diversity. We've recruited. We've gotten counselors to place students. But in general, we keep recycling those two things. And what really needs to happen for sustainability and for true change in this computer science world is for what happens in the classroom to have impact on students' interest in computer science, in their interest in it, whether it's to pursue a career or to pursue it in college. But do they want to take another course? Are they interested enough to say, oh, I see that it connects to something I really am interested in, like medicine? What are we doing to engage students, to be culturally responsive, to provide an inclusive, and I would say more than inclusive, a feeling that you belong in the environment in which your class is. So it's a big picture, right? It's a constant cycle. We can have access, but if we don't have good recruitment or reputation of courses, then we're not going to get the students in the courses. And of course, if we don't have the students in the courses, we can't even get to effectively teaching all students. So I'm going to switch on to Q&A. And again, stop sharing my screen. And please feel free to ask questions. And as Lynn said, you know, I can see you. That'd be great.
Hi, Gail.
Hi.
Hey, as folks are formulating their questions, I'm going to bring a few up on camera. Could you maybe start us off with sort of a more, general question? Like, in many districts, still, computer science is not a priority. And especially after COVID and the year that we've had, in academia and in K-12 education, there's so many other things happening in school districts, and it's partly funding. It's not always about funding. It's really about how do we prioritize computer science in the time that we're in now, but also to make it, important in the day and age that we're living in. Maybe think about that. And then after that, I'm going to bring some folks up on cameras as they're requesting to ask their questions.
Yeah. So if I had the answer to that one, probably we would be a lot further along. I mean, it's hard, right? It should not have to be an either or. I am not one of those people that thinks that computer science is more important than anything else. I think that we need all of it, and because we're limited by our, X number of periods a day education system, we continue to be in this sort of zero-sum game unless we find ways to integrate in larger schools, it's not as much of a problem, right? I do think that doing what we can to build awareness of what computer science really is helps. I also know from experience with some of the projects that I work on that we are also subject to the AP dilemma, right? AP in many schools is what drives everything. And then there's this forgetting conveniently often that AP, regardless of whether it's CS Principles or AP CSA, is still college level work. I mean, these are the courses that are being taught in colleges, and they're not taught the same way, but they're in high schools, and they're for students who are prepared to be in AP. That doesn't mean they have content knowledge. It just means they have school and sophistication and things like that. And the number of schools that have found ways to have a computer science course at the AP level is striking to me, when really we should be creating demand from students by offering a course that's accessible to a wider range of students. So I'll get off my soapbox. I'm not sure I answered your question, but that's my spiel for the moment.
Hi, Keith.
Hi.
Hi.
Can you hear me? Hi, how are you?
Yes.
I just wanted to speak. I was hanging in the background. I wasn't going to say anything, but I did when we first started looking into. I was around when all the talk about bringing computer science into school, and I went to ECS. I think it was 2015, Golden, Colorado. I did. I know it wasn't the first one, but and it's interesting because there were other people that was a part of that cohort that just showed up. I didn't know they were going to be there, but it was really a great course. And, you know, while I didn't go into computer science, but I did take computer science course in college. You're right. It's taught a different way. I went to computer science. The only reason why I got through that basic programming class is because I had a young man that had taken computer science at an academy that's not in my hometown anymore. So they were doing it back then in some places, you know, they was doing computer science. But in any event, ECS is a great course. I think it has evolved over time. I hadn't really looked at the curriculum in a while, but I'm seeing the cultural responsive thing now. But it's very difficult. And I think it's the experiences. That having the experiences very young. I believe you have to catch these kids in elementary. Computer science, but then the programming part. You have to. I've been having a hard time thinking about that, like those different titles. I mean, you know, you have the web designs and all that, but it's been extremely difficult. Now, I have kids that like me. I'm just that type of teacher. I can get them into my class, but they're not necessarily into the computer science. But that's okay. I get them in. But I've also had kids that has gone on that surprised me, that say, Mrs. G, I think I'm going to do computer science. And they went into computer science. They graduated from Georgia State. I have one now that's at Georgia Tech, but her father is in technology. Her sister graduated from computer science from Georgia State, and now she's in it. But it's just kind of hard to get those, you know, to get the mic, you know, just to get all the different kids in, the male, the gender, and if they like you, they're coming. Now, whether that means they're going to go to another course in computer science, I don't really know, but I have seen it done. And I will be teaching IDT again. I'm glad I just did the training with seismic at Georgia Tech, because I had a curriculum and it was okay, but it really, really pushed me to be creative. And it wasn't a great course, but I think this one is going to be a little bit different. So I'll be able to hopefully capture. And while I'm not looking to be looking really to go into programming, I have to get better with that so I can really better help the students. But I like the field. I know it does a lot for students. It covers the gamut. Every time you go somewhere, you see now the technology. Doctors are not bringing in books anymore. They're going to the dentist. Everything is technologically driven. So I think ECS is a great course, though. I like the course. I saw it as a combination of a couple of courses we got rid of in Georgia. Computer science and computing in the modern world. It had a lot of that feel to it because I've taught that as well. But it's good to see you again. And I'll still be around. I'm in middle school now. My first year was last year, and it's totally different. So you really have to engage middle school.
Which middle school are you at now?
I'm at Elkins Point in Fulton County this year. I did it last year, and man, it's different. Everything I saw in high school, I see double. I see double at middle school. So the engaging, exploring piece and getting them interested is more than a notion there.
Well, I appreciate your perspectives and you coming on and sharing that with us. Thank you, Keith. And Gail, you do have a question in the Q&A. It is from Scott. How do teachers get involved with ECS?
Where are you located, Scott?
Looks like California.
So we have, we typically work with regions that can offer, okay, Scott, so you should have no problem actually, because LA Unified is the home. And unfortunately, we just did, they just did their PD last week. And the other option in California is currently happening in Sacramento, which is literally currently happening in Sacramento. So this summer is no longer an option. But what we typically do is, you know, try to match teachers to a location that is local for them. So in your case, you would have a couple of possibilities. And if there's no regional PD associated with that particular spot, then we try to find somewhere else, but then there's, there are travel issues with that. So you can email me directly if you have more questions. I mean, just wait a couple weeks till PD for this summer is, but
okay, Gail, I think we are at time.
Okay.
So I just want to thank you for coming to the summits today. I know you are in between breaks with your other workshop, but I really appreciate you taking the time and sharing this information. You and I have discussed the potential to increase ECS opportunities in Georgia, and so I hope that we'll be able to continue those conversations, particularly for next summer. I think we're building momentum and, continue to work together on this, which thoroughly energized about that. So thank you.
Yeah. Well, and I'll look forward to talking more about that as we get started into the school year. So thanks for having me. Thanks everybody for being here. And
yes. And feel free to connect with me if for those that are in Georgia or in other states, if you'd like to connect with me, I'm happy to do that. And I'm happy to, pass along connections with you, Gail, as well, too. Some folks are interested in your slides. So if you want to be able to share a version of your presentation, I'm happy to provide that link to our participants, too.
Okay.
Okay. All right. Thanks, everyone. So Gail, we're going to be at break right now, and then another round of concurrent sessions are happening in just a few minutes.
Okay, well then I will say goodbye to you.
And then, yeah, it's a pretty full day, but I can't thank you enough for doing this. And I think I see a lot of potential, to bring opportunities for ECS next year. It looks like I'll be able to working on it, but it looks like I'll be able to secure some funds to get something started next year. And yeah, it won't happen until next year. Like nothing is until next year.
It shouldn't. I mean, it shouldn't, and that's good, right? And the only thing I'll say is, I think, as I said to you before, I wish you could do the PD in person, but I think just being part of it next week will be really good.
Yeah. So, okay. So we'll work on that. I'm going to jump off, Gail, because actually Dale is in a session.
Yay! Tell him I said hi.
I will tell him. But it's great seeing you, and
you too. And
I hope we can connect soon, for some lighter occasions.
Yes. All right.
All right, Gail, take care. Okay. Thank you so much.
Okay.
Really appreciate it.
Bye now.